So we discussed electronic configurations in a previous video. So I'd like to go a little bit further now. We talked about periods 1 and 2 electronic configurations, but let's talk about period 3 now. And I also want to point something out here, a shortcut that we're using right there. Okay, so the electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. Right? But we know that this is the electronic configuration for neon. And so what we oftentimes do is we simply shortcut it by putting neon there, right? And that symbol with the neon in brackets represents this 1s2, 2s2, 2p6, the electronic configuration of neon, okay? This is called the abbreviated electronic configuration, and it's great. Really helps us a lot, right? There is neon right there. And we can really save a lot of grief because we're not concerned about that. That's not where the action's happening. The action's happening on the outside, not the inside. So, all right, so the electronic configuration of magnesium is here. And notice that these two are in the S block, right? And the P block are over here, right? Let me go back here. Remember this is the P block here. Here's aluminum. Here is, that's our aluminum. Aluminum's down here. This is boron, carbon, nitrogen, oxygen, fluorine, and neon, right? Aluminum, silicon, phosphorus, sulfur, chlorine, and I don't know what that is. Maybe argon? Okay. So this is the P block over here. This is the S block, and we're going to use that to our advantage in just a second. Yeah, I don't think I'm going to show you anything else about this. It's just the orbital diagrams getting filled out and only showing the 3s and 3p. You can imagine the actual full orbital diagram is also going to show the 1s and the 2s and the 2p, right? So we've got our blocks, which I was just referring to. P block is here, the S block is here, and the D block is here, and F block is here, and that's because the outermost electrons are being filled or partly filled for each element that is in the S block. It's going to be S orbitals that are being filled. All the elements that are here in the P block are going to have their outermost orbitals being filled are going to be P's, and so on. Okay? So the S block contains elements in groups 1A and 2A. Whoops, the P block consists of elements in groups 3A to 8A, and the D block is the stuff in between. And the F block, I don't say anything about that. Okay, beginning in period 4, this is kind of weird. The 4S sublevel fills before the 3D sublevel or subshell because the 3D subshell is slightly lower in energy than the 4S, higher in energy than the 4S subshell. The 5S subshell fills before the 4D subshell, and so on. Right, so look at this. 1s2, 2s2. Look at that. Right, you see the 3D doesn't get filled yet. The 4S starts to get filled before the 3D does. Okay, and that's because the 3D is slightly higher in energy than the 4S. Okay, so more from your more electronic configurations and abbreviated configurations from your textbook, and more yet. Okay, so here's now we're going to get, I think, some magic. The guide to writing configurations using the sublevel blocks is awesome, right? So I'm going to demonstrate this first of all with hydrogen. Hydrogen is the sublevel block filling. The filled notation is 1s2, 2s, and 2p. Filled notation is that, right? So we just keep writing those across and filling them up. And you know what? Let's come back here and let's. I want to start that over again. Suppose that we're asked for selenium. We're asking for the electron configuration for selenium. So we go find selenium, and selenium is in its atomic number is 34. It's in group 6A in period 4. This is awesome. Okay, that means the last subshell being filled it's in the P block because it's 6A. So it's going to be 4P something, right? It's going to be 4P something. So we got to fill 34 electrons, right? So we first of all fill up the first subshell, and it goes to 2 electrons. So we now have 32 more to fill in, right? We had 34. We just filled 2 in, so 32. Then the second level gets filled. That's 8 more electrons. So 32 minus 8 gives 24 electrons to go, right? Now we fill in 8 more, right, in the third subshell. So we've got 16 to go, okay? And then we fill in 4s2 3d10. That's 12 more. So we've got 4 more to go. And that takes us into the P block, and so it's going to end with 4p4. Right, so the electronic configuration, I just sort of sped forward there. The electronic configuration then is 1s2, 2s2, 2p6. There's 10 electrons. 3s2, 3p6, 4s2. There's 10 more, that's 20. There's 10 more, that's 30. 34. 34, and that was the atomic number for selenium. Okay, I'm going to leave this in your book. I'm not going to say anything about this. I don't want to deal with the exceptions. There's 2 exceptions. They're sort of interesting. It'll make a lot more sense after you practice it. We'll discuss that in class. Okay, so use the periodic table to give the symbol and the name for the element with the electron configuration of blank. All right, so this is actually easier than it looks. I'm going to do this 2 ways. First of all, I'm going to go to the 3D7. I'm going to go to the periodic table. I have one here. It's going to be 1, 2, 3, 4, 5, 6, 7. It's going to be that guy right there, right, in the periodic table. So let's do a periodic table. One, 2, 3, 4, 5, 6, 7. It's cobalt, right? You see that? It's cobalt. Cobalt. And where was the question? It's down here. It's going to be cobalt. Okay, but I'm going to do one more check on this, and it's actually a little bit easier. This question, we had a little bit of shortcut. 10 electrons here, 10 electrons here, 7 electrons here, so it's going to be 27 electrons total. So I might as well just look up the periodic table, look for element number 27, something with 27 protons, and sure enough, there it is, cobalt. All right, a little bit redundant, but it's nice to see it in some sort of inside consistency. All right, so write the electronic configuration for each of the following elements. Please pause the video, write these out. You really need to see if your answer is the same as mine before you decide it's easy, right? Give it a shot. Okay, so I'm going to suppose that you pause the video, and I'm going to say carbon is 1s2. Let's come over here to the periodic table. Carbon is in the second period, and it's the P block. It's the second in the P block. So it's going to end with 2p6, right? It's going to end with 2p6. Not 2p6, 2p2. Right? It was the second one over in the P block. Second period, second one over, right? 2p2. So it's going to be 1s2, 2s2, 2p2, and that's it. We actually had that as an example in a previous slide here. All right, let's do silicon now. Silicon is also in the second column in the third period, second column in the P block, so it's going to end with 3p2. That's what it's going to end with. 3p2. And so everything upstream of that is 1s2, 2s2, 2p6, 3s2. And I'm going to do a check on this because I've got so many electrons here. 2 plus 2 plus 6 is 10, plus 4 more is 14. Is this 14? I'm going to come back over my periodic table, And it is. Silicon is 14. Bam. Good deal. So let's go now to oxygen. Oxygen is right here. It's the fourth column in the P block, right? 1, 2, 3, 4. So it's going to end up with P6. It's in the second period, so it's going to end up with 2P4. It's in the fourth column. So it's going to end with 2P4, right? And the beginning is going to look just like we had up there. 1s2, 2s2, right? Okay, and that's it. Now, I wonder if any of you use the shorthand notation, the abbreviated notation, because this really is helium, isn't it? Same thing. So you could have said helium 2p2. That would be also correct. It's the same thing, okay? And this one would be, right, a little too fast here, a little bit messy, helium 2p4. And this one, it looks like that's the same as helium there. So it would be helium 3s2, 3p2. You know what? This is not helium. That's not helium. Made a mistake. That is helium. Sorry about that. Somebody's upset about that. 2s2. 2s2. Okay. I'm going to rewrite this bottom one just to clarify. I made a mistake there. It's 2s2, 2p4. All right. Okay, I hope that's helpful.